Today, we're going to try to build a fencing referee, an AI detect fencing something referee, basically to make calls. We're going to focus on Saber, but the catch here is we're going to try to use ChatGPT to do all the heavy lifting, all of the programming concepts, everything important. Is it going to work? I don't know. Maybe. I'm optimistic. Let's go. So, let's see. Start by ChatGPT. I would like to build an AI fencing referee. Probably should have said please. All right. So, it's going to give us kind of some game plan here. So we want to do data collection, gather a data set. Okay, so we're just going to use a video clip from previous World Cup something Grand Prix. Pre-processing, process the video, extract relevant features. Action detection. So we'll do relevant features, we'll probably do isolating the fencers, segmenting their movements, extracting information as body position, and weapon movements. So we're going to try for body position, so like the torso, and weapon movements, that's going to be like the bell guard. So data collection, pre-processing, training computer models such as deep blah blah blah, classify different fencing actions. This should identify attacks, parries, touches accurately. So what we're going to focus on, we're not going to worry about too many blade actions because that's pretty standardized. You can look at them like, oh yeah, that's reasonable. There's some gray area, but not that much. So what we're going to do is focus on right away. So actions in the middle type thing. And since the Saber, everything kind of happens in the middle, don't have to worry too much about camera moving. So we'll start on that. Rule enforcement, blah, blah, we're not going to worry about that. Real-time processing, not going to worry about that. Integration, develop a user interface, not going to worry about that. Testing and refinement. So we're basically going to do the first three things. Data collection, pre-processing, action detection. Okay, so we'll start with data collection. Data collection. Let's start with data collection. With data collection. So we have, I downloaded a video. Did I do a video? Yes. So this was recent tournament, Plovdiv. I think Bulgaria. Let's take a look at the video real quick. So the game plan for this is we want to break it up into clips. So what I'm thinking is if we take this and we look at when the lights turn on, and it looks like they're pretty close to the box. They're not always synced up, but this time, let's see how this clip looks. Yes. Hop. It looks close. So the hit, light turns on for the overlay. So we can look at the overlay, where the light turns on from the overlay, and basically go a few seconds on both sides there. So now we take this video, you see we're at 310, I downloaded it. Now, let's take a look at the video. So here's our video, set as about 310, right about there. And what we're going to do is I'm going to take a screenshot with both these lights. So now I can go through frame by frame and look to see where those locations are. You'll see. So take snapshot, click. So what I'm going to do is I'm going to grab the location of these, the lights, the red lights and the green lights. And we're going to start with that. Since we know the locations, because the overlay stays the same for all of them. So now that we have the overlay, we're going to take this, close out of that. Nope, don't need to save. Go back to our Wolfram armor. So let's start with the data collection. I have a video in my Google Drive titled, and I'm going to put in the title. I'll just do rename, copy, bring it over. I would like to import this into Google Colab and display a random frame from the video, just to kind of make sure it works. All right, does that seem reasonable? All right, let's see what ChatGPT comes up with. Whoop, data collecting. Bump, bump, bump. Construct a random frame, blah, 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 blah. Display the frame using map. All right. Can you show me the entire code? That's why the code all in one segment. Bump, bump, bump. And excellent. Okay. Think this works? Does it work? Google Colab. We should probably title this. We'll call this, I don't know, data collection. Data collection. Yeah, close enough. Up and paste. So we're going to click on run, see what happens. Need to connect to my Google Drive. Can totally do that. So now it's running, mounted the drive. Pow! So it looks like it mounted the drive, and it can mount it pretty quick because Google Colab, Google Drive, so servers are close. I don't know. So even though it's 8 gigabytes, it downloads it quick. So mount the drive, and we have a random image from the video clip, which is a good sign. Okay, so now, excellent. So let's see here. So we have the frame, the video we had was, I think, at 310. So let's try and grab this one. So 3:11:21. So and then let's check, see how many frames per second this is. So properties, this video right here, details, is 30 frames per second. So please convert 3 hours, 11 minutes, 21 seconds, 11 minutes, 21 seconds, 2 seconds. So we have this many seconds. If the frame rate is 30 frames per second, which frame is at that seconds? Would be this. Okay. Please write a script to display frame that. So now we're going to try and take a look at that specific frame. Boom, boom, boom. Okay, probably don't need to mount the drive again, but you know, data is cheap. We're going to do it again. Hoop. And I'll probably mention that the drive is already mounted. It is. Excellent. And we got a frame that's pretty closely. Oh no, okay. Yep. Is that the same? Interesting. Same, about random. Right. So about right. So now we're going to, using frame that, oh, nope. Come back up here. Our using frame. And OpenCV. OpenCV is just an open computer vision. It's just a way of doing computer vision. It's an import library, not a big deal. Using frame and OpenCV, export or save images from the frame. And then we're going to use, let's see here. The frame, the first image will be from pixels, and we're going to do 296 comma 985 to, and this is, we're just going to be the corner points here, 640, comma 1000, and name it red light. The second image will be from pixel 1209, comma 985 to 1515, 1000, and save these in my Google Drive in folder, let's call it images. Yeah, seems good. Maybe. Second image will be from blah blah and named green light. And we'll save these images. Save these in my Google. Okay. Perfect. So now it's going to write some code to do this. Puts in the values. Click, 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 click. And it's thinking. Video path. Okay. So video path. Yep, it looks about correct. So let's see if this works. All right. So go to code. Click. It's going to say that drive is already mounted, which is okay. Image is saved successfully. All right. I have no idea if that's true. So they tried to save images. Folder path. I do have a folder images, and I have a green light and a red light. So now this is pulled from the overlay. So now, so we have our video. We're going to go through here and find out when there's one light or the other. All right, so now we're going to, all right, and we probably don't need to go through frame by frame. We'll do like, because there's a lot of frames. Let's do, I don't know, every 30 frames? That's every second? Yeah, let's do every 10, third of a second. All right, we'll get close. So we're gonna say, all right, go through the entire video clip. Okay, actually we're going to start by creating a CSV file. So we're going to create, it's basically a CSV file, comma separated variables, is basically like an Excel spreadsheet, but written in just, you separate each value by commas. It's basically the more efficient way of doing it in Excel spreadsheet, but just like data, notepad, very straightforward. So create a CSV file that, with three columns titled start, we'll call it starting frame, middle frame, ending frame, last frame. Test, so every 10 frames, test if the pixels at, and we're going to come back up here and we're going to look at our location of the red. So the red, actually we could probably come down here, red lights, and this are similar to the image red light JPEG. Also, test if, we're going to look at the green location, if that if the pixels at are similar to green line image. So this can basically test when the red or green lights go on. If it is, it will do every second. And I'm going to explain to it. It goes, so our goal is to capture when the lights turn on, and then record 3 seconds before and after the touch on the CSV file. So every 30 frames, and I will say 10 frames. Test if the pixels at this are similar to the image that. Also test the pixels that are similar to that. If it is, then record the frame number in the middle frame column and record 3 seconds before at the starting frame column and 3 seconds after, i.e. 90 frames, in the last frame column. So to record 3 seconds before, 3 seconds, i.e. 90 frames before, and then we'll call this, create a CSV file we'll call it just clips.csv. All right, so this is what we got. Let's just see what happens. So we'll see what ChatGPT gives us. So it gives a path, okay? Creates that, CSV file, creates the CSV file, frames, looks at position, maybe. The script we iterate over the frames, video for every time specified interval, check to the pixels regions are similar, there are similar calculations. So the we also don't want them to overlap. The clips should not overlap each other. Does the code check that there is no overlap between the starting and ending frames? Apologies, oversight, blah, blah, blah. It's not really an oversight, it's just being polite. I appreciate it, but it's my failing, not ChatGPT's. Region of interest, ROI. Man, I have no idea if this is going to work or not. And it's long enough that I don't want to check through it. I'm not even sure if I'd understand what's going on. That's okay. We're just going to do this and see what happens. Oh, and nice thing about this is if there's an error, we can just be like copy paste error in ChatGPT and see if it works. So ChatGPT, go. And the challenge here is that it's going to think for a while, and I didn't ask it to do any inputs to let you know how it was thinking. So I have no idea if it's working or not till it's done. And the video is like 8 hours, 7 hours long, so it could take a while. After 3 hours, finally got done. In hindsight, I probably should have done this a bit differently. If I had downloaded a lower resolution of the video, it might have gotten quicker. So, not sure what the bottleneck was, if it was loading or processing the image. Not a big deal. Long story short, finally got done, 3 hours. A couple things I changed in the code though was the ChatGPT gave us as an and statement where both lights have to be on, and I had that changed to an or. All right, let's take a look and see what we got here. Here's our CSV file, comma separated variables, and it basically gives a starting frame, last frame, and it goes all the way down. So let's pick one of these out. We'll do 100,000. Let's do 100,500. So we have 55 minutes, 50 seconds, 55 minutes. What are we at? So what are we at here? This is 55 minutes, 50 seconds, and we got a light turning on. So yes, it's not, I'm not saying it's correct, but I'm saying it's not obviously wrong, which is a good step towards being correct. All right, so now that we have this list of all the clips, we want to divide them into Saber and Epee, because I think we have Saber and Epee here. So the way I'm going to determine the difference between Saber and Epee, so this will be Saber, is I'm going to look at this right here, this time. I'm going to say 3 minutes, because they don't usually keep time in Saber. Unnecessary distraction. So I'm just going to look for that 3 right there and go from there. So what I'm going to do is I'm going to go back to my paint, paint, find this location. So we got 912, 975. Okay, yep, put that in. ChatGPT. Let's see, please. Let's see, how should we do this? So we need to get that image first. Ooh, so we can get that time. We know what that time that is. So this time here is 3:02:47. Convert 3 hours, 2 minutes, 47 seconds to seconds, and then convert that number of seconds into a frame, assuming 30 frames per second. So I'm just going to try and find out what frame that is. There might be a clever way of on the video. I don't know. We're just going to go with this. Bum bum bum. Yep, I don't need the explanation. I should probably just be like, don't give me, just give me an answer, not an explanation. Bum 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 bum. There we go. Okay. So now, extract the image from pixel. Let's see here what we got. 909, 935 to pixel 942, 978, and save it to, I think we have images, is where we're saving the images. Yep, to the folder images. Images on the Google Drive. There we go, and this should give us some code. Yes. Pum 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 pum. And it'll tell us successfully, which is nice. I appreciate that. Right. Come back down. Click. We're gonna have to mount the drive again, which makes sense. Why is that taking so long? Okay. None type image is none subscribable. Oh, can you modify the code to first load in the video? And I'm just gonna say load in the video, and hopefully you'll remember from earlier the specific name of the video that I wanted. There we go, video path. Because I don't think we had video path. Yep, we just had image path. Yes. And then frame. I'm gonna make sure it's right there. To pixel, blah blah blah, frame. So, and I'll say use frame this to extract the image. There we go. I think I was implying too much. I should have explained better what I wanted. All right, blah blah blah. Yes, 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 yes. Nice. So it has to go sequentially. So is it necessary to read the frames sequentially, or is it possible to jump directly to the desired frame? Maybe. Probably depends. So we do have an MP4, I believe. Let me check. It is MP4, so we can do it because it is MP4. Interesting. Did not know that. Blah, blah, blah. Let's go for this. Just to see if this works. So now we'll run this. Pow. Desired frame could not be read. Okay. Let's try the previous where we read them sequentially. Hopefully it doesn't take too long. Desired frame. All right, so hop. The error, and this is the error that was created by the code, so it's not unexpected. Desired frame, blah, blah, ensure the video path is correct. I should do that. My drive video, yes. That was my mistake. Well, all of this is my mistake, but that was definitely, please use the video file name that. I kind of feel weird when it apologizes because it's totally my fault, but it's still overly polite. All right, same idea, working through it. Boom, boom, boom. Yes. We're just gonna try and go through this. And image saved successfully. Okay, let's see if that is true. Images. Cropped frame image 3. And I'm going to rename this as so it's the time. I'll call it 3 time 3. So basically it's the there we go. Excellent, thank you. Now I want to go through, I want to check each clip in clips.csv and if the time, all right, so actually go to this. Thank you. I would like to create a new column in clips.csv. The new column's name will be weapon, i.e. Epee or Saber. For each clip, use a frame halfway between. So what we're going to do is we're going to go back. We're going to use a frame between the starting frame and the middle frame. That might be too much because there's 3 seconds between them. Let's just do like between the middle frame. Actually, we could do at the middle frame. That might be better. For each clip, use the frame at the middle frame. And if the location and I'll do it this way. Hopefully it'll understand despite my poor notation. Is similar to the image. Found in the images folder. Found in the images folder titled, and I'm going to have to give it a new title because it has no way to know that I changed the title. Titled this. So if it's similar to the video, titled this, then write Saber in the weapon column, else write Epee. Because we know it's either Saber or Epee. We'd like to create a new column, another new column name will be this. For each clip, use the frame at the middle frame, and if the location is similar to the image found in. Okay, so basically, yes. We'll see how this works. Could be disastrous. Go back. All right, so it's got creating some code. See what he said, blah, blah, comparison. Yep. Similarity greater than 0.95. Okay. And it looks like it's using pandas? No, yep, it is using pandas. Okay, it's just, pandas is just a data frame. It's just another way of doing things. Like fancy Excel spreadsheets. Let's go with this. Let's see if this happens. Do magic. And it should be pretty quick because there's so we're using for the video. So they didn't have they're not it's not picking up the video. So rename, grab the title. For the video, use the title for the video to load. Use the video we've been using. Use the video we have been using so far, titled this. So I think it was loading the wrong video. And we probably could have put that error, just copied and pasted it, put it in, and it probably would have done, we probably would have figured it out. All right, so same concept. And I could have changed this on my own, but I like it better this way. We'll see. All right, hop, and go. Okay, well that took longer than expected. I don't know why it took like 15 minutes. Long time, long time. All right, so now let's take a look at our CSV file. Hopefully it's kind of what we want. So we have clips.csv, and it has Epee, Saber. Interesting. Lots of Epee, some Saber. All right, so let's spot check a couple of these, kind of see what's going on here. So this is kind of, so let's look at 11,100. So let's do, can you write a code snippet that will extract, that will display frame 11,100. Let's see if it uses the same video that we have. For the video path, use the video we previously used. There we go. Oh, now let's copy this code. Take a look right here. Take a look at random video. We got this error. Hop, copy. So I received error. This. And there's kind of a patch, I think, for that. I have no idea why, just part of life. Copy, paste, try again. Boom. So basically what this says is that they were just warming up, and that's why you got the light, but no, and it had 3 minutes, or maybe it's during the break. That makes sense. So even though these are labeled as Saber, they're not. But we should have a bunch. There we go. So bunch of Sabers right here. Interesting. Let's try 341910. So let's do 341910. Is it 910? 910. Take a look at this one. Ah, but I had 0 right there. That's interesting. So I should have done 0 or 3. That's okay, that's okay. So now what I want to try to do is to look at, so I want to grab each clip and I want to try and find the score. So if I know the score, what I'll be able to do is I'll be able to tell what the director's call was, but also it's kind of cool to know. So we'll see if this works. So what we're going to try to do, we're going to try and take advantage of the overlay. So what I'm going to do is I'm going to grab a whole bunch of just scores. So for each middle frame, let's do, I think it's called middle frame. Middle frame. Oh, there we go. For each middle frame in clips.csv, take the image, extract the image from pixels, and what we're going to do is we're going to use the pixels right here, and right here. We'll start with the left side. So what we're going to do, come back here, extract the image from pixels, and so we know what the left score is. It's at pixels from pixel 790 931 to pixel 846 975, and save the image in the folder images slash, and then we'll do let's call it temporary temp. Yep. And this will be for the left scores. So we're going to get a whole bunch of left scores, go a bunch of right scores, and then once we get those, we'll compare them throughout. First meet frame, blah blah. Yes. From each middle frame, extract the image from the video we've been using from pixel there to that. Okay. So it uses the correct, yep, uses clips.csv, uses the correct file. And this will give me many, like 600 of these. Probably don't need 600. Do this for only the, can you adjust the code to do it for only the first one? Let's do 50 rows. That way it won't go quite as long, won't have quite as many to look at, because we only need the numbers 1 through 15. Hopefully the person on the left side wins. That way we'll be able to get all the numbers. Now all the change here is from here to 50, where I think above they just did it for each of them. So that was the only change probably in the code. So copy the code, bring it down here, code, go. And it'll think for a while. All right, come on, Mr. Lefty. 12, looking good. Still at 12. When you see doubles like this, I wonder if that means that the person on the right side got the point. Oh no, that person lost 2. All right, so now we're going to do 100 to 150. Same idea. Okay, so now what I've done is I've downloaded images of the left and right scores for all of them, and I got just 0 through 15. So now what I can do is, okay, now I want to add 3 columns to clips.csv. Maybe I want to add 5 columns. No, three columns. So the 3 columns will be labeled left score. I'll do an, there we go, right score and touch. Yes, so what I'm going to do is I'm going to have it identify the score and then who got the most recent touch. Oh, all the way down. Boom, boom, boom. Okay, so we'll see if this works. Might be disastrous. We'll see. Oh. So now we should be able to come back here. My drive, clips.csv. We should have left score, right score, and touch. Excellent. So now what we want to do is we want to analyze it. So how are we going to do this? So write a code snippet that goes through each. So I'm going to start by just doing the scores. So write a code snippet that looks at the middle frame and then analyzes and then checks if the image let's see here. So we'll start with the left side. So write a code snippet that looks at the middle frame and then checks the extracted image from pixel. And for the left side, we have 931. So we do 790. No. Yep, 790. Maybe 790, 931. Let's check that. 790, 931. Is that reasonable? 790. Yeah, maybe. 790, 931 to 846, 975, and tries to match it with each image. And we're going to look at images left score with each image in the folder images left score, and then it puts the title of the image in the column left score, i.e. if 1.jpg is the closest match, then if 1.jpg is the closest match, then 1 is placed in the column for right, in the column left score. So it sounds confusing. I don't know if that made sense or not. We'll see if ChatGPT can figure this out. So it does EVT, pandas. Now we could use optical character recognition for this. Since we have a consistent overlay, I think this will be more accurate and quicker. So it's going to go through each one and find its absolute difference. Yes. That seems very reasonable and possible. Use clips.cv. This might work. We will check. We will check. All right. This might take a while though, because it's got to go through, compare a lot of images here. I don't know. Maybe. We'll see how this works. There we go. 14 minutes. Man, that took a lot longer than I expected. Much higher resolution video than I should have gone for. Right, so now go back to clips.csv, see how this looks. Did it not update? What's going on here? Left score column updated. So let's see here. So it just got done updating. There it is. Interesting. I was expecting them to be much more sequential than that. How can I make this more accurate? Could you further explain SSIM, Structural Similarity Index? Can you modify the code to use SSIM? Maybe. I don't know. Because it's literally, this should be the same image, since this is computer. Meh, let's go with this. "40 minutes later, looks like the analysis done. This time we used SSIM, which was some sort of structural, what does it stand for? Structural Similarity Index. Method? M is probably maybe method? I don't know. Anyway, let's take a look at this. So it looks much more reasonable. So they seem to be going in order, which is what I would expect. And you see doubles here because it probably means those are right score. So I'm going to say, actually, that looks really good. Adequate. Right. So now I'm going to do, can you alter the below code so that it uses the folder right score? Make sure I get the folder named right score, and instead, and saves the values in the column clips.csv right underscore score. So this is going to do the same thing, except it's going to do the right side now. So we did the left side, we'll do the right side, and then we'll be able to find out what the scores were, what the referee called. All right. Hope, got all these. Huzzah. Ooh, what's that? Sky skimmage? Oh man, so much stuff I don't know in life. Folder path, images right score, the column is updated right score, the column because it matches data frame. Sure. Let's just go for this. Let's just go for this. Confidence. Confidence. Random code, don't know what's going on. Yeah, confidence. Fortune favors the bold. At least, maybe not in coding. All right, so. I did not adjust the, yes. So, for the extracted image, instead, I should have seen this coming, so we're going to use 925 comma 975, use pixel. So this is the upper left pixel to pixel 1050, comma 1150. This was my mistake. All right, so we have some new code. And I'll say, can you print out every, I don't know, say 25 rows is complete. That way I'll kind of get an idea of how long it's going to take to do this. Nice, this would take so long for me to code this myself. Assuming I was even that competent, which is kind of sketchy, questionable. And that's, yep, that uses modulus. So if when you divide, if the number of rows is a multiple of 25, then print this out. All right, see if this works a little bit better. Maybe. So it seems to be thinking, which is a plus. Excellent. So now we have the right columns done. Let's give it a gander, a look. Clips.csv. Yes, and it looks like they kind of go up incrementally. So start to 0, 0, no touch. So yes, that seems reasonable. Okay. All right, so now, excellent, thank you. Excellent, that worked great. It's always good to be thankful to the help from our robot overlords. So now, now I would like to modify clips.csv. The left score represents the score at that point. And the right score at that clip, at the beginning, at the start of that clip. And the right score represents the score at the start of that clip. I know it sounds like I could do that, word that more clearly. I'm just trying to be as succinct as possible. The touch column represents who received the point for that clip, for the specific clip. For the touch column represents who received the point for the specific clip. I want to, can you write a code snippet? So I have a code snippet that looks at the next row and determines who received the point based on how the scores increment. If both scores increment, and the weapon is Epee, then the touch will be both. If only a single score increments, then the touch column will be either left or right. If the scores do not increment by a single value, then use the phrase NA for the touch column. All right, so lots of words there. I don't know how much sense it makes. We're gonna see if ChatGPT can figure out what I was trying to imply. Certainly, here's a code snippet, blah, blah, blah. So we got the NA, lots of if-then statements, if-else. Man, glad I don't have to do that by hand. And this should happen super quick because it's just looking at the chart, looking at the CSV file. So let's see if this works. All right, so this is our file now. We want left, right, both, or NA. And weapon should be lowercased. So that was my fault. I fed in bad data to ChatGPT. Bam, already updated. Let's see what happens. Maybe? Interesting. So right touch. Could be exactly the same. We're going broad strokes here, so if it's kind of okay, I'm kind of okay with it. Okay, so let's look at some of the sabers. Here's some Saber stuff. Looks like Saber. So we had left touch, right touch. These seem to be kind of reliable. So let's look at one of these and see if it's okay. So we're going to look at this frame right here, see how this works out. So it's going to be force. Excellent, thank you. Now I would like to create a MP4 file using the middle frame of 466050, 466050, create a video clip, create a video clip from the starting frame to the ending, final, is it ending frame or, how did I call that? Whoop. To the last frame. Create a video clip from it and save it to my Google Drive. Yes. Use a descriptive title, and we'll let it figure out the title. We want to spot check this one. That's 466050. 466050. There we go. Maybe. Let's just see if this works. Spot check it, see what happens. All right. Ready for this? This code seems to be taking a while. Is there a quicker way to do it? Since the video file that we are clipping from is quite large. Taking too long. Pause solution. Performance use the video. Processing language for video trimming without decoding. Encoding the entire videos. Ah, yes. Let's do FFmpeg. So maybe. So let's take a look at our drive. Make sure we're not doing anything yet. All right. Let's see if this works. FFmpeg. Hop. Anyways, can you add a print output that lets us know when every 30 frames is complete. I know there's only like 180 frames, so maybe we'll see. Hop. Import subprocess. I have no idea what that library is. That was so much faster. Did that work? I have no idea. Video clip saved to Google Drive. Where did it save it? It called output video. Okay. Where is this output video? There's an output video right there. 217 megabytes. That's big. Download. Download anyway. I know. Danger. All right, so let's take a look at our video now. So this is supposed to be our clip 60, is it 6050? We'll take a look here. Oh, there we go. There we go. So this should be Saber and the score should be 2-0. So now let's take a look at the actual video. If it'll actually pull up. Is it downloaded yet? Yeah, it should be downloaded. I am having trouble playing the video file using VLC. Feels like what could I be doing? What could I be doing wrong? There we go. Video box skipping. Nope. Nope. It could be a few different reasons. Verify the file path. Check the file compatibility. Sure that was. Codec requirements. All right. Let's look at the properties of this. I don't know. Maybe. Let's try a different codec. Could you modify the code to use 2 seconds before the middle frame and 1/2 second after? Also, can you use a different codec that might work better for me to open the file using VLC? We'll see if this works. Long shot. Maybe. I have no idea. We're just going to go with this. Maybe. So I'm supposed to save it to output video, MP4. We're supposed to be at a different. Maybe. Just change the name. So ideally, it should be 2 seconds before, 1/2 second after, which should be 2.5 seconds. It should be, should be less than 90 frames. Should be a better way of doing this. Alright, this is many more frames than I expected. Oop. Let's try this again. Let's try this again. Let's try again. Can you create a video clip with 2 seconds before and 1/2 second after, 0.5 seconds after the middle frame of is it let's just pick one. Pick another one. Pick a value. Saber 447510. 447510, and save it to my Google Drive. Choose a format that could work with VLC media player. Certainly, blah blah blah. Very nice. Alright, so let's see here. This does for each line the process standard output. So it's how many seconds, 2, blah blah. The video file is a large file. Is there a quicker way? Is there a quicker? Actually, we'll give this. We'll give this a try. See how this goes. Seemed quick. Let's see what the video file's name should be. Should be output video.mp4. So we have output video. Oh, I had 2. It might have just taken a while for that to 363 bytes. Probably not correct. So we have 1234. Maybe it takes a while for that to show up. Let's look it over here. Download. We'll just download this straight from 217. That was just... No, that was done a while ago. Let's try this. Whoop. So it's creating that file. It seems to be kind of slow. Should be doing more than 90 frames. Oh, this code seems to be taking a while. Is there a quicker method? Movie.py, maybe. Okay, let's try this. If the video file already exists, will this replace the existing file? Yes, okay, that's what I wanted. Oh, I received the error. I'm just gonna put the error straight into ChatGPT. Oh. And this video frame FPS should be 30. But it's going to get it from the actual original video, which is nice. Output path. Yeah, seems reasonable. There we go. I have no... Ooh. Save. I have no idea what just happened. Done. Maybe. Okay. Let's take a look here. So 1252. Maybe. Let's refresh this. All right, so let's look at some video files. All right, so we're gonna try this. Take a, okay. Let's take a look at this. Hop. Click. So this is using moviepie.editor. Never used that before. No idea. We'll see what happens. Hop. Writing video. Okay. And let's see if this is what this is 44750. We'll look and see what this is supposed to be. So this is, there was no point awarded, and the score should be 6.8. So come down here, save to Google Drive, go to my Google Drive. Let's see, is it here? Is it here? Not here. Is it just a delay thing, or was it not actually saved? It says it was created and saved. Maybe I just need to be more patient. Hop. Drive. My drive. I don't seem to be. So done. My drive. Output video.mp4. I don't see it. Let's try this again. I know I'm probably just going to cause extra trouble. Let's see. Content, drive, output video. Yep. Done. Okay. There it is right there. There it is right there. Okay, let's download this, take a look at it. So it says no touch was scored, and the score was 8.6. So it might be just them testing. Take a look. Here we go. Aha, it is. See, because it said both lights, 6.8, no score. So it's like, yeah, seems reasonable. All right, let's grab another one that's a little bit less, a little bit more interesting. Let's do, so I'll say Works great. Works great. Can you modify the code to be can you modify the code to change duration after to 1 second? Just a little bit longer. I know I could do it myself, but I kind of just want it to have it up here. Perfect. And let's grab another one. So let's come down here. Epee, Saber, there's some Saber. We'll do 466050. Have we looked at that one before? Maybe. So we'll do, grab the code. Oh, can you also name the output file based on the middle frame used? There we go. That way we just won't have output video. We can kind of look and be like, oh yeah, that's what the video is. All right, we'll see if this works. Copy, paste. I said 46050. 466050. 466050. Let's see what happens. And you have to do the output directory and file name. Ah, there's no output videos. Can you modify the code to check for the output videos folder and create it if it does not exist? There we go. Then I'm gonna have to update the middle frame as well because, yes. All right, see how this goes. Copy code, plug in code, and we're doing 466050, 466050, 466050, and go. Ooh, nice. I have no idea what any of that means, but it looks cool. Okay. So now there's probably a folder, a new folder here, output videos, and I can download my output video that's named based on the middle frame. Now let's take a look, see how this looks. Yes. So, see? Nope. That was the previous one. This one. So let's take a look. So it looks like we have the complete action there. They start, they go. It's exactly what we want. And let's see, the score is 2-0. I'm gonna say touch left. Let's see if that's correct. So, so my drive, clip CSV, we did 466050, and it was called touch left. Very nice, 2-0. Excellent. So, what we have now is the ability to collect frames. So we can collect, so we have basically a CSV file, which is a list, it's just a list, and we broke down the entire video this video we downloaded, and I should have used a lower resolution. I didn't. Lesson learned for next time. Like this 8 GB, 7-hour video, and we broke it down into these frames. This is the starting frame, the last frame, and the middle frame. The middle frame is when the lights turn on. That'll be, it doesn't always sync up. The lights of the overlay don't always sync up with the actual lights from the box. So that's not going to be perfect, but hopefully good enough, especially for this, because I just do a couple seconds on each side. And then I used, I was able to find the left score or the right score at every given point, and I did that by comparing two images using a method called SSIM, structural something something something. I should know that. I just looked at that. I've used it before, but I'm not familiar with it. And looking at the score, then I was able to determine which touch we had. For Epee, it looked a little bit flaky, but I don't care about Epee because Epee directing is awesome. Well, there are few objections to Epee directing. Though it always seems like every time there is an objection and it's over some super important point, it's always 14-14 or tied up with a couple seconds left. And there are always edge cases and always terribly hard. But Saber's more, the directing on Saber is more interesting, more nuanced. That's why I'm looking at it. So I have a bunch of Saber clips, and we have scores and touches, and hopefully we can use these clips then for computer vision and then analysis. So now that we've got all the clips, next up will be computer vision and breaking down the location of the parts. So we'll see how that goes. Pretty exciting. See you on the next one.